What is refraction? Refraction is the bending of light or other waves as it passes from one transparent substance into another. What are some examples of refraction in everyday life? Examples include lenses, magnifying glasses, prisms, rainbows, and the focusing of light in our eyes. How does refraction affect our vision? Without refraction, we wouldn't be able to focus light onto our retina, essential for clear vision. What causes refraction? Refraction is caused by a change in speed when light travels at an angle into a substance with a different refractive index. How does the change of speed lead to a change in direction? When light enters a substance where it slows down, it changes direction. What determines the amount of bending in refraction? The amount of bending depends on the change in speed and the angle of the incident ray. What happens when light enters a substance with a higher refractive index? It slows down and bends towards the normal line. Give an example of light entering a substance with a higher refractive index. When light travels from air into glass, it slows down and bends towards the normal. What happens when light enters a substance with a lower refractive index? It speeds up and bends away from the normal line. Provide an example of light entering a substance with a lower refractive index. When light travels from water into air, it speeds up and bends away from the normal. How is the angle of refraction affected by the angle of incidence? A greater angle of incidence results in a more noticeable refraction. How are angles measured in refraction? Angles are measured from an imaginary line drawn at 90 degrees to the surface of the two substances, called the normal. What is the normal line? The normal line is an imaginary line drawn perpendicular to the surface of the substances where refraction occurs. How does the refractive index relate to the speed of light? A higher refractive index indicates that light will slow down more as it enters the substance. What is the refractive index of air? The refractive index of air is approximately 1. What is the refractive index of glass? The refractive index of glass is typically around 1.5. What is the refractive index of water? The refractive index of water is approximately 1.33. What is the refractive index of diamond? The refractive index of diamond is around 2.4. Describe what happens when light travels from a high refractive index medium to a low refractive index medium. It speeds up and bends away from the normal line. Explain the behavior of light when it travels from a low refractive index medium to a high refractive index medium. It slows down and bends towards the normal line. What famous experiment did Isaac Newton perform involving refraction? Isaac Newton used a prism to show that white light is made up of all the colors of the rainbow. What is the acronym used to remember the colors of the rainbow? The acronym is ROY-G-BIV, representing red, orange, yellow, green, blue, indigo, and violet. How did Newton demonstrate that each color of light cannot be turned into other colors? He showed that each color refracts at slightly different angles and cannot be transformed into other colors. Can the colors of the rainbow be recombined to make white light again? Yes, Newton demonstrated that the colors can be recombined to produce white light. What causes the separation of colors in a spectrum? The separation occurs because each color of light has a slightly different refractive index in the medium, causing them to refract at different angles. How does the refractive index of red light compare to violet light in glass? The refractive index of red light in glass is 1.513, while for violet light, it is 1.532. Why does violet light refract at a slightly greater angle than red light in glass? Violet light slows down more than red light, leading to a greater refraction angle due to its shorter wavelength. How can a rainbow be created artificially? A rainbow can be created by spraying water into sunlight, causing the light to refract and form a spectrum. What is the center of a rainbow always aligned with? The center of a rainbow is aligned with the shadow of the observer's head on the ground. What causes the secondary rainbow, and how does it differ from the primary rainbow? The secondary rainbow is caused by light reflecting twice inside raindrops, resulting in reversed colors compared to the primary rainbow. What is total internal reflection? Total internal reflection is the complete reflection of a ray of light within a medium back into the same medium, occurring when the angle of incidence exceeds the critical angle. When does total internal reflection occur? It occurs at the boundary between two transparent media when the angle of incidence is greater than the critical angle. What is the critical angle for total internal reflection at a water-air surface? The critical angle is approximately 48.5 degrees. How does the critical angle vary with wavelength? The critical angle varies slightly with wavelength due to differences in refractive indices for different colors of light. How are glass prisms utilized in optical instruments? Glass prisms are shaped to produce total internal reflection and are used in binoculars, telescopes, and periscopes. In what other applications is total internal reflection important? Total internal reflection is crucial in fiber optics, where light is conducted over long distances through multiple internal reflections in glass or plastic fibers. What materials can exhibit total internal reflection? Any transparent medium with a higher refractive index than its surrounding medium can demonstrate total internal reflection. What determines the critical angle for total internal reflection? The critical angle depends on the refractive indices of the two media at the boundary. How does the phenomenon of total internal reflection benefit optical instruments? It allows for efficient redirection and manipulation of light rays, enabling the design of compact and powerful optical systems. What role does total internal reflection play in the functioning of periscopes? Total internal reflection allows periscopes to transmit light from the object to the viewer without the need for direct line of sight, enabling observation from concealed positions.